In this video, I want to go over something called logarithmic differentiation. And you're going to want to do something like this when you come across a variable raised to a variable, okay? So the first step you want to do is you want to take the natural logarithm of both sides so you can get this variable exponent moved out in front, because that's a property of logarithms. When you take the logarithm of something, the exponent within inside the logarithm can get moved out to the front as a constant. So if we took the natural logarithm of both sides, so this would be ln of y is equal to the natural logarithm of x to the x. This exponent right here can get moved out to the front as a constant, and that's a property of logarithms. So if we rewrote this as that would be the natural logarithm of y is equal to x times the natural logarithm of x. And from here, now we can take the derivative of both sides with respect to x. Okay, so when we start with the left-hand side, we're going to have to implicitly differentiate the left side because we're taking the natural logarithm of y with respect to x. So we have to implicitly differentiate. So the derivative of ln of y is 1 over y times, and then we have to multiply it by dy dx because we're implicitly differentiating, is equal to, we're going to have to use the product rule to multiply or to find the derivative of x, ln of x. And the way you do it is you take the derivative of the first, so that's 1, times the second, ln of x, plus the first, x, times the derivative of the second, which is 1 over x. Okay, now we can simplify this up a little bit. On the right hand side, we can rewrite this as the natural logarithm of x plus 1, because x times 1 over x is just x over x, and x over x is equal to 1. So I just did that real fast. And this is going to be 1 over y times dy dx. Now we want to solve for dy dx. We're going to need to multiply both sides by y to cancel this out. So if we multiply this side by y, it'll cancel. And then multiply this side by y, we will end up with dy dx is equal to y times the natural logarithm of x plus 1. And we're pretty much done from right here. But what we can do is, you see this y, if you look up here, y is equal to x to the x. We want this back in terms of just x. So we can rewrite this as dy dx is equal to, and instead of y, just replace it with what y equals, x to the x. So x to the x times the natural logarithm of x plus 1. And that is the answer to this problem. So for this problem, we have y is equal to x raised to the e to the x. And we're going to go about it the same way. We need to take the natural logarithm of both sides because we have a variable raised to another variable up to a power with a variable in it. So we're going to take the natural logarithm of the left-hand side is equal to the natural logarithm of x e to the x. Okay, so by the rules of logarithms, we can take e to the x and move it out to the front, this exponent right here, move out to the front, and that's going to be equal to the ln of y is equal to e to the x times the natural logarithm of x. And now we can take the derivative of both sides with respect to x. And just like last time, the left-hand side will have to be implicitly differentiated because this is a y variable that we're differentiating. So the derivative of ln of y is 1 divided by y, but we also have to multiply it by dy dx is equal to, and on the right-hand side we have e to the x times the ln of x, so we're going to have to use the product rule. And it goes, the derivative of the first and the derivative of e to the x is just e to the x times the second, the ln of x, plus the first, e to the x, times the derivative of the second. And the derivative of ln of x is just 1 over x. And then this isn't absolutely necessary, but it'll help it look cleaned up a lot more. You see we're multiplying ln of x and 1 over x by e to the x. So we could actually factor out an e to the x, and this would be equal to the ln of x plus 1 over x. Okay, and on the right hand side we have the same thing, 1 over y times dy dx. So now we need to isolate dy dx to solve for dy dx, and we're going to do it just like last time. We're dividing by 1 over y. We need to multiply by y. These cancel, and we multiply this whole thing by y. We're going to get dy dx is equal to y times e to the x times the natural logarithm of x plus 1 divided by x. And from here, you see we have just a y variable. We can look up here to see y is actually equal to x e to the x. So we can replace y with x e to the x, and we'll be left with dy dx is equal to x e to the x times e to the x times the natural logarithm of x plus 1 divided by x. And this is the answer to this problem. So for our next problem, we have y is equal to x raised to the power of sine of x. So in order to get this sine of x off of the exponent, we need to take the natural logarithm of both sides. So we're going to take the natural logarithm of y is equal to the natural logarithm of x sine of x. And now we can move this exponent out to the front due to the properties of logarithms. So this is going to be equal to the natural logarithm of y is equal to sine of x times the natural logarithm of x. And now we can take the derivative of both sides with respect to x. So just like the other past examples, the left-hand side will have to be implicitly differentiated because we're taking the derivative of y with respect to x. So the derivative of the natural logarithm of y is 1 divided by x, but then we have to multiply 1 divided by y. Then we have to multiply by dy dx because we're implicitly differentiating is equal to, and on the right-hand side we're going to have to do the product rule again because we're multiplying sine of x by the natural logarithm of x. So we're going to take the derivative of the first and then multiply it by the second, and you know how we did it. So the derivative of sine is cosine x times the first, which is the natural logarithm of x, or times the second, which is the natural logarithm of x, plus the first sine of x times the derivative of the second, which is the derivative of ln of x is 1 divided by x. And then from here, we can actually clean up the right-hand side a little bit by multiplying sine of x by 1 divided by x and get sine of x divided by x. So we can set this equal to cosine of x times the natural logarithm of x plus sine of x divided by x. Okay. And then this, the left-hand side is 1 over y times dy dx. Okay. So from here, we can multiply both sides by y because we're trying to solve for dy dx. So if we multiply this side by y, these cancel, and then we multiply all this by y. This will equal dy dx is equal to y times the cosine of x times the natural logarithm of x plus sine of x divided by x. And we have this y here. We want to get it in terms of x again. So if we look up here to what y equals, y is equal to x sine of x. So if we replace y with x sine of x, we will end up with dy dx is equal to x sine of x times the cosine of x times the natural logarithm of x plus sine of x divided by x. And this is the answer to this problem. So for our last problem, we have y is equal to the square root of x times e to the x squared times x squared plus 1 raised to the 10th power. And at first this looks like ridiculous, but it's actually not that bad. We're going to go about it the same exact way. So we take the natural logarithm of both sides. So ln of y is equal to the natural logarithm of the square root of, so the square root of x is just x to the 1/2 power. We're going to rewrite it as x to the 1/2 power to make this easier. Times e to the x squared times x squared plus 1 raised to the 10th power. Okay, so before I go applying the properties of logarithms, such as moving the exponents out to the front, I want to make sure that you guys know, before I go about writing it, that you see how we're multiplying this x times e times x squared plus 1? Well, the properties of natural logarithms, if you're multiplying things by the inside, that's the exact same thing as taking the natural logarithm of x plus the natural logarithm of e plus the natural logarithm of x squared plus 1. So before I went about writing that down, I wanted to explain that to you first before I go and confuse anyone. So that's what I'm doing here. I'm bringing out 1/2 to the front as a coefficient. So there's going to be 1/2 times the natural logarithm of x plus, I'm going to do the same thing throughout here. So plus x squared times the natural logarithm of e plus 10 times the natural logarithm of x squared plus 1. And if that still confused you, this isn't a logarithmic differentiation misunderstanding. This is properties of logarithms misunderstanding. So go review the properties of logarithms. So the left-hand side remains the same, ln of y. So now we are ready to differentiate both sides with respect to x. So the left-hand side will have to be differentiated x implicitly. So this is going to be 1 divided by y times dy dx is equal to, the constant just comes along for the ride, and the derivative of the natural logarithm of x is just 1 divided by x. So this is going to be 1/2 times 1 divided by x plus, so the natural logarithm of e is just 1, so we can actually cross this out, and because x squared times 1 is just x squared. So we'll use the product rule to differentiate x squared, and that'll leave us with 2x plus. So we're going to need to use the chain rule for this problem. The constant 10 will just come along for the ride. But since this is an inside function, x squared plus 1, with inside a larger outer function, the natural logarithm, we're going to have to take this derivative using the chain rule. So we'll take the derivative of the outside first, and the derivative of the outside is 1 divided by x squared plus 1 times the derivative of the inside, which is just 2x. But we can't forget this constant. We have to multiply this by 10, this whole thing by 10. Okay, so we need to do a little bit of simplifying. So 1/2 times 1x is just 1 divided by 2x plus 2x is fine, it doesn't need to be simplified, plus 2x times 10 times 1 divided by x squared plus 1 is just 20x divided by x squared plus 1. And the left-hand side remains the same. Okay. So what we need to do now is we need to solve for dy dx. We can do that by multiplying both sides by y. So this is going to be equal to dy dx is equal to y times 1/2 x plus 2x plus 20x divided by x squared plus 1. Okay, last step, we're not done. This y right here needs to be written back in terms of x. As you can see up here, it is the square root of x times e to the x squared times x squared plus 10. So we can rewrite this whole thing as dy dx is equal to y is actually this right here. So we're going to write that square root of x times e to the x squared times x squared plus 1 raised to the 10th power times 1/2 x plus 2x plus 20x divided by x squared plus 1. And this whole thing is the answer to this problem.